So in the next problem, we're looking at two parallel wires. And imagine the dot is an arrow, the wire that is looking at you, and the second wire with the X is the wire heading away from you, the direction of the current, that is. And you notice that there's two graphs here. One where the distance P is equidistant from both wires, and then the second one is where distance P is not. In order for us to be solving the problem with what we are given, we have to assume that the case is for the left-hand side figure, because we don't know the angle otherwise that point P makes with the two. We're not given anything about that, so we have to assume that it's the perpendicular, point P is perpendicular to between the two distances from wire 1 and wire 2. And if we use Ampere's law, which says B dotted with dl equals mu naught I enclosed, then we can say that this is the same as B dl cosine of the angle theta between L and B, which equals mu naught I enclosed. And we've done this before, where since the magnetic field is not set, we're trying to find it, but we're not saying told anything about it not being uniform. We can say that this is B times dl cosine of theta. We can take the distance to be in the same direction as the magnetic field, because if we look at, if this is I1, then we will have a magnetic field B1 coming out of it, and then we will have a magnetic field B2 coming out of it for I2. So we can say that B and L are parallel, and that will mean that theta is 0, which means cosine theta is 1. And if we complete this process, we can say that this is B integral of dl equals mu naught I enclosed. And as we've done before, this is 2 pi times the distance between the current and the point is r, so this distance dl would be 2 pi r, because it's throughout, equals mu naught I enclosed, or that B equals mu naught I enclosed over 2 pi r. And now we can say that B1 then is going to be mu1 I1 over 2 pi r, and similarly B2 would equal mu naught I2 over 2 pi r. If we notice that this is a perpendicular angle, or 90 degrees, then this is the point P, and the first wire and the second wire will give us R, R, D, and the right triangle. So we can say that because these are equilateral, these distances are the same, then the angles in here have to be 45 degrees, right? Because the total angle in a triangle must be 180. And so now if we know the distance d, and we know the angle between them, we can find that what r is, and we can say that cosine of 45 degrees is going to be r over d, which means that r is the same as d cosine 45 degrees, which means that b1 equals mu naught I1 over 2 pi d cosine 45 degrees, and b2 is mu naught I2 over 2 pi d cosine of 45 degrees. And now, since we have the two components of the magnetic field, we can say that B in magnitude, B total, is going to equal square root of, and notice that the way the geometry is, if this is 90 degrees between the R's, it has to be 90 degrees between B1 and B2. So we can have this, say, mu naught I1 over 2 pi d cosine 45 degrees quantity squared plus mu naught I2 over 2 pi d cosine 45 degrees quantity squared. And we can take a factor of mu naught squared over 4 pi squared d squared cosine squared of 45 degrees, and we're left with I squared 1 plus I squared 2. And that way we can say that B total is going to be mu naught over 2 pi d cosine theta times the square root of I1 squared plus I2 squared. And now we have all the values that we need. Mu naught, if you remember, is 4 pi times 10 to the minus 7 Tesla meter per amp. 2 pi d is given as 5.3 centimeters. Cosine of 45 degrees times the square root of I1 is given as 15 amps. Quantity squared plus I2 is given as 32 amps squared. And that gives us a total magnetic field of about 1.89 times 10 to the minus 4 Teslas. And the last thing we need to find is the angle. So think of, now we have B1 pointing that way, B2 pointing this way. So if we complete the parallelogram, we know that, assume that's a straight line. This is B. We have an angle theta here. So theta is going to equal tangent inverse of tangent would be opposite. Opposite is B1. B1 over B2, which is going to give us Notice because all of the terms are the same between B1 and B2, the only thing left would be is tangent inverse of I1 over I2. Everything else cancels, which is tangent inverse of I1, which is 15 amps, over I2, which is 32 amps. And that gives us an angle of about 25 degrees. But notice that this is still B1 and B2 are still 45 degrees from. So this angle that B does, let's call this angle phi. Then phi is going to be 25 degrees plus 45 degrees, which is 70 degrees from x-axis.